So today we want to introduce a difficult question in a basically calculate a limit, and I think this limit is the most difficult limit which I was seeing before. So I want to make a video and discuss with you guys and share with you guys this interesting limit. Okay, so this limit x about limit x to 0. The numerator is sine tangent minus tangent sine, and let me see. It should be arc tangent, arc sine, x minus arc tangent, arc sine x. And the limit s to 0, go to 0, and ask about what is the answer. What is the answer? Okay, so in the first view that okay, so in the usual in a calculus, that people like to use the L'Hopital rules, right? Suppose you have limit go to 0, f divided by g, if f of 0 and g of 0 basically 0, then you guys will go to do the differentiation and keep applying. And if f prime 0 and g prime 0 are still 0, then you do it twice. And until you get the answer. Okay, so this is the traditional way. Okay, so but unfortunately, okay, let me try a little couple examples to show the traditional way. So this is the common question. Ask this. Basically, you can use cosine differentiate sine 2x, and you see sine 0 is still 0, and the 2 times 0 is also 0. So you differentiate both respect to x again. So you get cosine x and 1 and 2. So it's very happy that you get half. Okay, so we differentiate twice. Okay, so this is the way that people like to do this. Okay, however, so you see if I should sine 0 tangent 0 is 0. So if I plug x equals 0, I will find the numerator is 0 and the denominator is 0. So I need to do the differentiation. Okay, so I use mathematica to. Okay, so let me first remove this term, remove this, and let me show you guys. Okay, so suppose I do differentiation with respect to x and f and g. Then so this is f and g, right? And I do a differentiation with respect and g. So you get you see this is the answer. However, if I plug x equals 0, I do x equals 0, then I got answer 0. So this tells us that I need to do the differentiation from this. Do this again. I need to do the twice differentiation. Okay, so what I will get is this. So let me do the second differentiation and show the results to you guys. So you see, when I do the second derivation, again, this is the second derivative of f. It's already very cumbersome. And I have the second derivative g. And then the poor thing is it still got 0. So I need to differentiate third again. So what we need to do is I still need to make a differentiation to the third. And the poor thing is that it still become complicated, and the answer still be 0. So I mean it sucks that I already did 3 times derivative. I still get 0. And you see this term is already very complicated. I mean if I keep doing that, then it sucks, right? Okay, so the problem is that if this is f, this is g, then if your computation power is very very large, then you can show that until you do the seventh derivative, the answer will be non-zero, and actually the limit is equals to 1. Okay, so it sucks that there's no easy ways to get this answer. Obviously, if you use a L'Hopital rule, it it looks like you keep differentiating until you do it 7 times, and then if you do it 7 times, then both f and g contains like 100 terms. Then it's impossible to do it by hands. Okay, so how about I show this is one. One way is I use the Taylor expansion. So I let me show this. If I do a Taylor expansion for f go to 10 turns, then I get this two. I get a 7 turn, so 7th power turn, and I get g, I get also 7 power turn. If I use f divided by g and x to 0, then the answer is 1. The answer is 1. So now the question becomes that so we see if we keep differentiating, then it's impossible to get the answer. So is there any way we can solve the limit without using mathematica, or basically without any computer help? Then we just try to get the answer. Okay, so the answer is yes. The answer is yes. Okay, so let me write the limit again. So basically we have sine 10 sine x and what, and tangent inverse sine inverse minus tangent inverse sine inverse x. Okay, so we can so the answer is yes. There is a geometrical way that we can prove it. Okay, so suppose this is xy plane and this is y equals to x. Okay, suppose you have two functions. One is f of x and one is g of x. Okay, so in our case that if you let f is just sine tangent and g is just tangent sine, now what you have is limit just limit x to 0, f minus g and g inverse minus f inverse. Okay, so once you understand this, then you will probably solve it. So if I plug draw x line here. Okay, so I can take a minus sign. It becomes like this. Okay, so you see this is g minus f. So this distance is g minus f, which is positive. Okay, and I can draw another distance. Basically this is x, right? So this is x. So this point is what? This point is f inverse, and this point is g inverse. So this distance, this clean blue distance is f inverse minus g inverse. So which tells that the limit when x goes to very close to 0, then this distance minus this divided by this distance just close to this this line, right? Just close to this y equals x. So the answer is just the slope of this line, slope of y equals x. So the answer is 1. Okay, so this is why I find this limit is very interesting, because usually people like to use the L'Hopital rules, basically the traditional rules, but there you can construct some limit which are very very difficult to find, even though you have a computer. I never tried to use mathematica to compute a 7th derivative for some special function, because I sometimes took a lot of time. Okay, so this is my share today, and be sure to subscribe to my channel, and I will see you guys in the next interesting videos.